very useful properties which follow from their definition and the equivalence of the logarithmic form and exponential form. These properties of the logs are used to solve logarithmic equations, simplify logarithmic expression or equations. Here are the very useful properties of the log. So first is, if you have log b m times n, it's a multiplication of two numbers or two variables. So it's a multiplication property of the log, which is also equal to log bm plus log bn. So here is how it goes. If the question is written like this one, then you might have to make it like this. And by converting it to that way, you will find the answer by cancellation or by doing the process the exponential way. If in multiplication you have a plus, therefore if you have log bm over n, this means minus, right? So log m minus log bn. Then if you have an exponent of the log, you have log bm raised to the power a. That's an exponent there. So you can multiply the exponent with the logarithms, with the logarithm number. So you can have a log bn. Right? So you are multiplying the exponent to the logarithm. Okay, that one would be log if you have a radical log. What does it mean? So this means you are going to have log bn divided by 2. Right? So log bn divided by 2. Can you see that? Okay. So if you have cube here, that means you are going to divide it with 3. If you have fourth root here, that means you are going to divide with 4, and so on. Here are the very useful properties of the log that we are going to use in solving or simplifying logarithms. Alright, so for all these properties, as you notice, we have a base and our answer there. Right? So let's take this one for example. So for all of the properties, you have to note, so we have a note here, that b should be greater than 0. Right? Take note. So b should be greater than 0. Okay, it must be 2, 3, 4, 5, 6, and so on. And b, that's why I didn't mention 1, cannot be equal to 1. Why it can't be equal to 1? Because the answer is always 1. So, see, for example, if we're going to translate log 1, and you have an x equal to any number, let's say 4. See, when we translate it to an exponential form, it will be equal to x equals 1 raised to the power 4. Right? So 1 times 1 times 1 times 1, that's 4 times. You will have x equal to 1. Right? So b right here cannot be equal to 1. And another thing is that m and n should be greater than 0. Okay, so it should be greater than 0 right here. So it can be 1, but again, you are going to get like this. Or you will have a 0 power. But m and n should be greater than 0. Alright? Okay, so you have to note also that log b1 is equal to 0 all the time. Alright, so later on when we simplify the log or solve the equation, we would perform the conversion of the log to an exponential form to get the exact actual number. So you have to take note that log b1 is always equal to 0. Always equal to 0. Why? Because when you have log b here, it would also be 1. So any number that you are going to put on b, it will be equal to 1 all the time, because you will have that as 0. So if you are going to translate it back to exponential form right here, you are going to have 1 equals b raised to the power 0. So any number that you are going to write on b or substitute in b, it will always produce 0 as the answer. Okay? And another thing is, you have log b and b. Alright, so you have same number for this. Okay, so this should be equal to 1 always. Always equal to 1. B and b. Why? Because they have the same number. Okay, so if you have two similar numbers, that means equal to 1. Equal to 1. So this means, if we're going to translate it, this would be b equals b here raised to the power 1. See? It should always be raised to the power 1. Why? Because you have to produce the same number on both sides of the equation. Okay, let's have an example on how to simplify properties using the properties of the log. Okay, let's simplify this expression, logarithmic expression. So it's an expression because it doesn't have an equal sign right here, right? So how to do with this? Now, if you're going to look at this, we are given a expanded form. What do we mean by expanded? That means this like longer version of the property of the log. So if you're given like this, it's easy to make it condensed, right? So we can, what do we mean by condensed? So that means we are going to combine it. We use the opposite property of this. Right? So this is a minus, right? So we have a multiplication. So this is divided later. It will be divided later because that is what is found in our props. Okay, so there are two ways to solve this. Either we are going to go expand it more to simplify it, or condense it to simplify it. So let's go to expanding it more. Okay, so this is a multiplication here, so we can have log 2x plus log 2y. That's a divide. That means you are going to divide that, or let's just say, because we are not going to do it in the condensed form, so we are going to write, simplify it using the expanded form. So we will go with minus 2 log 2x. Alright, as you can see, there are 2 log 2x. So you can crush out one of it, and you can crush this one out, right? Because you are going to have minus, alright? So log 2x minus 1 log 2x. So you will have 1 log 2x there, alright? So what is left is log 2y minus log 2x, which later on you can combine and say the answer is log 2y over the x. So for this case, we can have two ways again. Okay? Two ways. Okay, so this is method number 1 using expanded form. Right? But we can also do, what we can also do is the main side here, the minus sign, will be our division sign. So it will be converted to our division sign. Okay. So we can say that this is log 2 xy over x squared. You can also say it like that. And since that is a multiplication there, and this is divided, so we can crush out 1x, right? I know you get my idea. Okay, so we crush out 1x here, and we crush this x out. So you can have log 2y over x. There you go. So earlier was using the expanded form. This one is what we call condensed form, so we condense it. So that's example number 1. If we're going to look at the logarithmic expression here, we have 8 multiplied by an x raised to power 2, and then 2 multiplied by y below. Alright, so that's a division, so it becomes minus later on. Okay, so we can say, I'll just make my handwriting a little. So we can say this is equal to log 2 8. Let's it's multiplied, so plus log, okay, 2, because you have 2 there, log 2x minus means this division, log 2, or take note of that same thing there, same number. Okay, take note of that same number there. Plus log 2 y. Okay, so log 2 and log 2y. Alright, then we can simplify them using cancellation and making all of these numbers here. We can have the exact number of this. In your calculator, you can have log the answer, that's 8, divided by log the base. Or you can convert this to exponential way. This means 8 equals 2x. So what is the x there? Right? So 2 times 2 times 2. Alright? So that means 8. Right? So you can say this is 3 here. And then this is plus 2 log 2x. Then how about that? This becomes 1 because you said, remember what we said earlier, b and b there, they're the same, so that means equal to 1 plus log 2y. Okay then, I think it should be good to put a bracket here. Why we are going to do that? Because you remember that this minus should be distributed, right? So it's better that on one side we can put bracket. Okay? So this becomes minus, this becomes minus also. Alright? So since that becomes minus there and this becomes plus, because we're using we're using minus and plus in our process, the expanded form. So we can then say that okay, this 1 here will go where? Here in 3, right? So we will combine this number and this one also. So you can have this now equal to 2. And since that's an x and that's a y, then we can write plus 2 log 2x. Then okay, so that means minus, see, plus minus, okay, minus log 2y. This is now our answer. Okay, so we can translate it back in this format, and you will find out that you are going to have a simpler expression than that one. So there are still, it can be reduced, number can be reduced here, somewhat like that. Alright? I think this is quite easy, no? So the principle here is that if you are given this way, multiplication, you have to add it. Multiplication, you have to add it. And you have a division, then you have to minus between that. And then refer to the one in the middle, the operation that is on the middle. If you like my content, then please do subscribe.